Hey guys, in this lesson we discuss about single sign-on. I will first start with explaining the challenge of authentication, and then I will explain about the single sign-on protocol that is available for use with web services which address the challenge of authentication. In particular, we will discuss SAML protocol. So, what is the challenge of authentication? The challenge is that not all the services used by Bob are managed by the same party. Assume Bob is an SMU student. He would have an ELAN account with SMU. He would also have an email account with SMU. But the thing is that behind the scene, in fact, email service is provided by an email service provider. ELAN is provided by a different service provider. They are different parties, although both services are provided within the premises of SMU domain. So that is the challenge of authentication. The challenge is that does Bob need to create an account for each service? Because if that is the case, it would mean that Bob will have to remember a separate password for each service. In addition, Bob would also have many other services like INET, library databases, Google Drive, Microsoft Student Service, and so on. So last week we have discussed about authentication between a client and a particular single server, which is relatively straightforward. We discussed that there is a choice of reasonably secure authentication protocols, weak authentication, strong authentication that we discussed last week. But the challenge here is a little bit different. It is about authentication to many different servers. So having a separate user account on each server will be the solution, but it will not be ideal for our poor user Bob because it means that he will need to remember many different passwords. So the solution that is being proposed, so the solution that we're going to discuss is authenticate to a dedicated authentication server. Why don't we just have a dedicated authentication server so that that authentication server can take care of sending out the information about our little guy, Bob, that he can be trusted. So let me give you a more concrete example. So this is the example of how so-called single sign-on solution work. Basically, let's look at our INET website from SMU. So you can think of INET as a dedicated authentication server from SMU. So you would only need to log into INET once per session. And the session, how long the session lasts would depend on the actual implementation of the single sign-on solution. Sometimes it lasts a day, sometimes it lasts a few hours, sometimes it lasts a week, sometimes a month, and so on. So if you look at this website here, you will see that there's a bunch of links which would actually lead to services hosted by different parties. In fact, for example, finance services, research grant services, HR, IITS, legal, travel, and in particular, if you look at the Microsoft, there are services provided by Microsoft, and there are services provided by Google, such as Google Drive and so on. And you can see that if I click into those links, you don't actually need to log in again. You don't actually need to authenticate to the Google service again, although clearly these services are hosted and managed by Google, not SMU. So how does the authentication process work? How is it possible? It is because of the single sign-on solution being used by SMU. SMU is here, it is serving as the dedicated authentication server, and it will handle the authentication between the Google and you on behalf of you. So SMU use single sign-on service. In particular, it uses the SAML protocol. So that is the idea behind the SAML protocol. I will need to introduce the terminologies first. The Asserting Party is the source website like SMU, and then there are relying parties like Google, Microsoft, and so on. Those relying parties has the resources that can be accessed by the web users, but behind the scene, the asserting party and the relying party must already have a pre-existing trust relationship, just like SMU and Google and Microsoft has. So the idea behind is that the web user would only want to log into the asserting party once every session. And then whenever this web user wants to use the resources um, from the relying party, this asserting party will take care of sending out the information about this web user to the relying party. So that is the idea behind. In fact, there are many different single sign-on implementations, but SAML protocol is the most widely used single sign-on service for web services. It is the short for security assertion markup language. And the latest version that we have is the SAML version 2.0, which was published in 2005. As the underlying technology, it is using public key infrastructure, which is also known as asymmetric crypto system, which we should all be very familiar with. And the idea behind is, again, the user is allowed to access websites in multiple domains without having to re-authenticate after initially logging into the first domain, which is the asserting party. But before that, those different domains must already form a trust relationship before they can share such an understanding about who the user is. So let us look at some definition of this asserting party, relying party. Essentially, as the asserting party would provide assertions about the users, which is called a subject to the other applications within this trust network. And the asserting party is also known as SAML authority, which is basically a system or administrative domain that asserts information about the user. And the asserting party would assert that the user has been authenticated, and this user will be associated with some attributes like the ID of the user, the email address of the user, and how the user was authenticated. In this example, the assertion says that the user is authenticated by using a password mechanism. And the asserting party would send such an information to the relying party. So, still it is up to the relying party as to whether it trusts the assertion provided to it. So basically, before it simply trusts that assertion, it has to verify something. The verification is about whether this assertion is really come from the asserting party itself. And this verification process is none other than the digital certificate, digital signature verification process that we have discussed in the past few lectures. And also there is one more thing that the relying party can decide, even though the trust has been verified, the relying party still can decide what kind of operation this subject can perform on the local resources owned by this relying party. And that problem is known as the access control problem, also known as authorization problem, which is a topic that we will discuss in the next upcoming week. So let us look at the nutshell. This is how the SAML protocol works. So the same thing here. We have the browser, which is used by the human being user. There is a asserting party, a server, and there is a relying party. So how it works? First of all, the user must be authenticated through this asserting party. And this user wants to access certain resources owned by the relying party, just like the SMU and the Google Drive example. So first of all, the user would browse through a website owned by this asserting party, in which it may contain links to those external resources. And by clicking the link, essentially, this user is sending a request to the asserting party. And since the user has already been authenticated at the asserting party knows who the user is. So the asserting party would prepare artifacts. I will explain about the artifacts a little bit later. prepare the artifact and send it back to the client by a HTTP redirect. So artifacts is basically base 64 encoded string. For example, it looks something like this as an example. It wouldn't make any sense, but in fact, it is a unique reference. It provides a unique reference to the actual assertion that is prepared by the asserting party. So it is also known as the assertion handle. So the clients obtain the artifact from the asserting party. And in fact, the browser will handle this redirecting. So it will simply redirect the artifact sent by the asserting party to the relying party. Okay, so in fact, this is a redirect process. The client make a request, the asserting party prepare the assertion, and then it provide the artifact that points to the assertion back to the browser. The browser will redirect back to the relying party so that the relying party receive the artifact, and then it can use that artifact and send a SAML request to the asserting party. And when this asserting party receives such a request, based on the pre-existing trust relationship by using this public key infrastructure, which essentially means that behind the scene, there is a digital signature, signing, and verification process involved, then the asserting party will know that the relying party can be trusted and vice versa. And then once this relying party sends the artifact to the asserting party will simply send back the assertion about the user back to the relying party. And that's how the relying party knows who the user is without the user having to log into the to this particular relying party website. So that's how it works. So if you're wondering how assertion itself look like, this is a simple example. Of course, it's not the complete information, but it contains some important information that is typically contained in the SAML assertion. So it will contain about the issuer, who is the asserting party. Issuer is the asserting party. In our example, is the abc.com, and it will contain the digital signature, which is signed by this issuer. So that's basically to establish the trust relationship between the asserting party and the relying party. And it will contain the information about the identity about who the subject is. Basically, this is the unit ID of the user. And then this is the targeted audience, which is the relying party. In our example is xyz.com. And this is the important information. It is the authentication statement saying that about this particular user, about how this user has been authenticated to the asserting party. And it will also contain the certain attributes associated with this particular user. For example, like the affiliation of the user and some other information like emails and so on. And so that is how the assertion look like. And this assertion will be prepared by the asserting party. And when the relying party send a SAML request to this assertion by providing the artifact, the asserting party will return back this assertion information. And then it is up to the relying party to verify this digital signature. And then based on the authentication statement, then the relying party can decide what to do with this information. All right, so this is the last important slide about single sign-on. So behind the scene, I've been stating many times that there is a pre-existing trust relationship between asserting party and the relying party. And the important security mechanism behind this trust relationship is based on the use of public key infrastructure, which obviously will involve digital signature signing and verification process. And it will also involve, because whenever you use digital signature, it will involve the use of public key, then it would essentially require the use of digital certificate. And that is how the relying party can trust what is being asserted by the asserting party. And if you have understood about this public key infrastructure lectures, you should be able to imagine how this digital signing and verification involved in this single sign-on protocol. Thank you very much. That's all about single sign-on. and see you next time.